In our last class, we discussed about the principle of homogeneity and significance of dimensional formula. So, with the help of dimensional formula, we can check accuracy of the given equation. Any equation is given to us, we can check it. The equation is correct or not. In our last class, we discussed about this. Depends on the principle of homogeneity. What is the principle of homogeneity? According to which the dimensions of all the terms on two sides of an equation must be same. We can add or we can subtract or we can equal only same physical quantities. This is the principle of homogeneity. We can't add velocity to the mass. We can't subtract velocity from mass. So both sides of the equation, that means LHS and RHS of an equation must be the same. Then only we can add the physical quantities. This is the principle of homogeneity. So in our last section we discussed that the accuracy of the given physical equation. So now let us check deriving a correct relationship between different physical quantities. Deriving a correct relationship between different physical quantities depends on principle of homogeneity. One problem is given here. To deduce an expression of the time period of a simple pendulum, the factors on which the time period may possible depends on the following: mass of the pendulum m. Next is length of the pendulum L, acceleration due to gravity g, and the angle of swing of the pendulum theta. Now let us deduce the equation. So this is the principle of homogeneity, according to which the dimensions of all the terms on the two sides of an equation must be the same. Now we can derive a correct relationship between different physical quantities. The problem given is one simple pendulum is there. This is simple pendulum. Mass of this bob is, this is bob. We call this as bob. Mass of this is m. And length of this simple pendulum is L. So the simple pendulum is swinging. It makes an angle theta. Here m is the mass of the simple pendulum, L is the length of the simple pendulum, theta is the swinging angle. So here time period of the simple pendulum t depends upon t proportional to m power a, mass of the pendulum. Next, t proportional to L power b, t proportional to acceleration due to gravity g, t proportional to swinging angle theta. So t proportional to m power a L power B G power C theta power D. So when we remove the proportionality symbol, we can get the proportionality constant. Power A, L power B, G power C, theta power D. Next. So now T is equal to K M power A L power B G power C theta power D. So dimension formula of T is T, dimension formula of M is power A, L is length, L power B, G is gravitational acceleration due to gravity, small g. Capital G is universal gravitational constant, small g acceleration due to gravity. Theta is the ratio of same physical quantity. So theta, no, dimensions. So T is equal to M power A L power B plus C T power minus 2C. So what is the value of M is here? According to the principle of homogeneity, equate the both sides of the dimensions. A is 0, B plus C is 0, minus 2C is equal to 1. So A is equal to 0, B plus C is equal to 0, C is equal to minus 1 by 2. From this, B is equal to 1 by 2. So the equation is T is equal to K into M power 0 L power 1 by 2 G power minus 1 by 2. So the relation is T is equal to K into root L by G. Like this, you can calculate we can deduce the expressions. How can they related with each other? We can find out with the help of dimensional formula here. So the problem is given in steps. K is the proportionality constant. We can't find out by using this proportionality constant using with the help of dimensional formula. We can get only the value of K by doing the experiments. So here the relation is T is equal to K root L by G. The value of K is deduced by you getting experiment is 2 pi. Next one is for a particle to move in a circular orbit uniformly, centripetal force is required, which depends upon the mass m, velocity v, and the radius of the circle. Express centripetal force in terms of these quantities. Let us deduce the relation. So one particle is moving in circular path. Radius of this is r. Radius of this is r. So centripetal force helps the particle moving in this circular path, that is F, and mass of this particle is m. So Fm proportional to A. Next, F proportional to radius of the circle r, and the particle is moving with the velocity v, that is c. So let us derive the relation. F is equal to K is proportionality constant, m power A, r power B, v power C. What is the dimensional formula of force? M L T power minus 2. M L T power minus 2. So MLT power minus 2 is equal to m power A. Dimension formula of mass is m. Next one is radius, means length, L power B. Next one is velocity of the particle v. Its dimensional formula is LT inverse. So here value of A is 1, B is 1, no, wait 1 minute. A is 1, L power B plus C. So B plus C is equal to 1. C is equal to 2. C is equal to 2. So B is equal to -1. C is equal to 2. A is equal to 1. B is equal to -1. So the relation is F is equal to K into M. C is equal to 2. So M V square by B is equal to -1. So R. So this force is required to move particle in a circular form. Here the value of K is 1. So F is equal to mv square by r. Like this, we can derive the equation for the given relationship. Steps are given here for deducing the relation. So let us see. Depends on principle of homogeneity. According to the principle of homogeneity, dimensions of on both sides of an equation must be same. So the equation derived is F is equal to mv square by r. The value of K can't be found by the method of dimensions. Just a number, it can be found experimentally. So, okay, thank you. If this video is helpful to you, like it, comment it and share it to others and subscribe it.